Hello Marvels, I'm back and I'm going to talk to you a little bit about the back side of your homework from tonight, where you have a summary table for the graphs of tangent, cosecant, secant, and cotangent. And I'm just going to show the graphs here on the screen and talk through the different characteristics of each. So for tangent of x, the domain would be all real numbers. There's really no limits except for where we have undefined values at the vertical asymptotes. So it'd be all real numbers except pi over 2, 3 pi over 2, 5 pi over 2, etc. As far as a range is concerned for tangent of x, it'll be all real numbers. This graph is always increasing, and this graph is decreasing never. The coordinates of the relative maximum points, well, there are none. Considering there are no parabola-like shapes, there's going to be no relative maximums or minimums. And there are roots. The roots of this function are located at 0, pi, 2 pi, 3 pi, 4 pi, and so on. The location of the vertical asymptotes occur where the graph is undefined, so pi over 2, 3 pi over 2, 5 pi over 2, 7 pi over 2, etc. And the period is just 1 pi, so that's a difference from sine and cosine graphs. The period for the tangent graph is just 1 pi. This function is odd. Remember, odd functions look the same if you flip them upside down, so take a good mental image, and when I rotate this, this also could be tangent of x. It's still increasing always and decreasing never. So that means this is an odd function. All right, moving on to cosecant. Okay, for cosecant of x, the domain, again, is going to be all real numbers. The range would be all values such that y is less than or equal to -1, and also y is greater than or equal to 1. So the only values that are not included are between -1 and 1. So all values such that y is less than or equal to -1, or y is greater than or equal to 1. These functions increase from pi over 2 until 3 pi over 2 would be increasing. It would be decreasing on intervals like 3 pi over 2 to 5 pi over 2. So increasing on this portion of the graph, decreasing on these portions of the graph. The coordinates of the relative maximum points, the maximums are occurring here and here. There's one here as well. So that would be like negative pi over 2, 3 pi over 2, 7 pi over 2. It has relative minimums above the x-axis at pi over 2, 5 pi over 2, and it would also be like 9 pi over 2 over here. The location of the roots, well, there are none since it never crosses the x-axis. The asymptotes I have in here would be at 0, pi, 2 pi, 3 pi, 4 pi. The period of this function is 2 pi, just like the related function of sine of x. This graph is actually also odd because if I were to turn it upside down, this is the exact same function as it is right side up. All right, moving on to secant. Right, so the secant of x, it's a much smoother transition. Secant of x is going to be very similar to cosecant of x. The domain, again, all real numbers you can put in there, aside from the values that give you undefined. The range is going to be the exact same from y is less than or equal to -1, and y is greater than or equal to +1. So y goes greater than 1, and y's can also be less than 1 for the range. It increases from 0 to pi and decreases from pi to 2 pi. The coordinates of the relative maximum points for this graph are at pi, 3 pi, and would be 5 pi. The local relative minimums are at 0, 2 pi, 4 pi, 6 pi, the even values. For this particular function, there are again no roots because this function never crosses the x-axis. The period of this function is 2 pi, and this graph happens to be even. Remember, an even graph, if you clap your hands together and open, it's the same on both sides of the y-axis. Well, what I've given you here is really just mostly quadrants 1 and 4, but here is the y-axis, and if you look at it, there is symmetry around it. So since it's symmetrical around the y-axis, we would call this an even function. And I'm ready to go on to cotangent. So the last one we're going to talk about tonight is cotangent. And cotangent is very closely related to tangent. Remember, you can find cotangent by taking cosine divided by sine. And the domain here, again, would be all real numbers, aside from where the asymptotes are located. The range is all real numbers without any restrictions at all. This graph is increasing never and decreasing always. So that's exactly opposite of tangent of x. There are no relative maximums or minimums on this function, and there are roots located at pi over 2, 3 pi over 2, 5 pi over 2, 7 pi over 2, etc. The vertical asymptotes for this function are located at 0, pi, 2 pi, 3 pi, 4 pi. The period of this function is only 1 pi, just like tangent has a period of 1 pi, cotangent only has a period of 1 pi. This function is odd, because if I were to flip it around, again, this function is still only decreasing, never increasing. It's the exact same upside down as it is right side up, which means that this is an odd function. Thank you for listening. Hopefully the information I just shared with you would really help you fill out the backside of your homework sheet where you have the summary table. And I welcome any comments or questions that you might have. Talk to you later.